Okay, the video notes for today are over another notes over characteristics of functions. So take great notes and make sure that you have them in class with you tomorrow. Okay, so the first example is a review from what we did Monday, and let's look at this example. Let's look at all the aspects, the characteristics of this function. So first thing I want you to do is always to label the endpoints of each, label the points at the end of each graph. So this would be 4, -2, -1, 4, -5, -3. Okay, and then we're going to go through and find all the possible x values. So the lowest to highest domain here would be -5 to +4. Okay, -5 to +4 would be all the possible domains, and I put brackets around it because it includes those points. And then the range, what's the highest and lowest range for this problem, would be -3 to +4. So I'm going to put -3, +4. Okay, the y-intercept spot where it crosses the y-axis, I'm going to go ahead and say that's about 0, 3. Obviously, you could put 0, 2.75 or something along those lines, but this would be okay for the y-intercept. The x-intercept would be this point right here. Where does it cross the x-axis? And this point right here. We're going to go ahead and say the x-intercept there is -3, 0, and 2, 0. Okay, the point where it crosses the x-axis. All right, on down the asymptote. There is no asymptote. Remember, that's only with exponentials. Only exponentials. Okay, that we'll be talking about asymptotes with. Okay, and then growth and decay is the same thing here. Okay, and then intervals of increase and decrease. So you can see that as this problem is moving from left to right, that it's increasing here and it's decreasing here. Okay, so remember, we only look at the x values. It's increasing from -5 to -1. Okay, so we say parentheses -5, -1, and it's brackets. Brackets because it includes that point. And then also now it's decreasing from -1 to +4. Okay, so we say -1, +4. Okay, so we won't do end behavior. We'll do that here in 1 second. Okay. All right. Next problem here. Label the endpoints. First thing we're going to do is let's say that it goes to there, which is -5, +5, and this point over here, this is 3, 3. This point right here, which is a point where it changes as well, is -1, 3. Okay. So first of all, the domain, the possible x values, the lowest x value is -5, the highest one is 3. So I say -5, 3, brackets because it includes those points. The range here, the lowest y value, okay, the lowest y value is +3. That occurs here and here, and the highest y value is 5. So the range here is 3, 5. All right. The y-intercept, the place where it crosses the y-axis, is here at 0, 3. That's a coordinate point, so we use parentheses. Okay. The x-intercept, it doesn't exist. It never crosses the x-axis. The asymptote is not important here. Neither is growth or decay. And then the interval of increase and decrease. So it never increases as you're moving from left to right. It is never increasing. It's only going down. It's going down from here to here. Okay. So I would say it's decreasing from -5 to -1. Okay, decreasing from -5 to -1. Okay, and then it's never increasing. Right. What this is called right here, okay, which is we have not talked about, is called an interval of constant. Okay, so if it's straight across, it's an interval of constant, and that would be from -1 to +3. Okay, so we'd say -1, +3, brackets there. If it asks us for an interval of constant. Okay, And then today what is new is what we call end behavior, okay? So take a second and write that down and pause it if you need to. It's what happens at the ends of the graph, okay? Each problem will either approach infinity, negative infinity, or an asymptote, okay? So we say this is what we say every single time, okay? Every single time. The first one, it says, as x approaches positive infinity. What that means is the right side of the graph, okay? This one says negative infinity. What that means is the left side of the graph, okay? What is happening to the left side of the graph, okay? This one, what is the y value doing, okay? What is the y value doing? The y value here is going to negative infinity, okay? And the y value here is getting closer and closer to the value of 0, because there's an asymptote there. So we say that a y value, as x is going to the left side, what is the y doing, okay? As x is going to the right side, what is the y doing? Question mark, okay? That's what we're answering every time, okay? So the right side, it goes to negative infinity, and the left side, it goes to 0, okay? It's going over here to 0, the y value will be 0, okay? The next one, the end behavior here, as x goes to infinity, what's happening to the y value, okay? It's going up, so it's going to positive infinity. So we're going to say positive infinity, okay? The left side, what is happening on the left, okay? This, remember, represents left. This one is the right, okay? And it's normally always in that order, okay? You just know positive infinity means right, negative infinity means the left, okay? So the left side, that's clearly going down to negative infinity, okay? So we say negative infinity there, okay? Two more examples here. The end behavior here, this right side, you can see the right side of the graph is going to positive infinity, it's going up. And the left side also is going to positive infinity, it's going up, okay? So both of these, so what I want you to know is it will not always be negative infinity, positive infinity. It may be both positive infinities here, okay, or maybe both negative infinity if it was going down, okay? And then the last example down here at the bottom of the screen, what is happening at the right side? That's going up to positive infinity, okay? So the right side is positive infinity right there. And then what's happening at the left side of the graph? That's approaching an asymptote. There's an asymptote right here. And anytime you're approaching an asymptote, that asymptote is y equals 0. So we say that the end behavior there is 0. It approaches that asymptote, okay? If, for example, there was an asymptote, let's say we had a graph like this, and the asymptote was here, okay? Let's say that we have an asymptote that is at -3, for example, okay? Then the end behavior here would be that as x approaches negative infinity, y approaches -3, okay? So it could be whatever the asymptote value is, okay? In this case, it's 0. In this case down here, it's -3, okay? So that's all that this video is about, is mainly about end behavior. So that's it.